Alright, Timurea, welcome to this tutorial where we are going to look at derivatives, the laws of derivatives. So we'll start with the power rule. The power rule So the power rule is like this. You've got your variable there, I set to the power something. So ddx using the derivative of that function with respect to x is equal to this. The same power multiplied by the x variable or any variable you have. In this case we've got x, then that power to be subtracted by 1. This is the power rule. So for example, we've got something like this: x squared. To differentiate this will be the derivative of x, the derivative of this function with respect to x. So you should see something where there is n there. We've got 2. This is our function. This is f of x. This is our function. Even here, this is our function. So you can see where there is n there, we've got a 2. So you just have to follow this formula and do your derivative, work out your algebra from there. So let us drop these two, write it like this, because you can see this n has come there to multiply the variable x. So this will be multiplied by the variable x, then this power to be subtracted by 1. So the derivative of this is equal to 2x to the power 1, which is just 2x, like this. So this is how you go about it using the power rule. So there is one thing I would like to mention here before you proceed any further, because you encounter this later when you do implicit functions. So let me do this. So let me do this because you encounter this later when you do derivatives of implicit functions. Let me erase this. Okay, let's do this. Okay, so there is this secret which I have to show you here. Let's say you've got this f of x is equal to let's say this is x to the power n, like this. So when you want to differentiate this, you can say this is same as y. Where there is f of x, you can put y is equal to x to the power n. So remember, as Christians, you guys, you say whatever you do to the right hand side, do it to the left hand side. So here, finding the derivative of this equation here, or this function, you're going to introduce the derivative both sides. So here it will be d with respect to x, the derivative of y with respect to x, like this. Even here, the derivative with respect to x of this function. It's like this here. So now here, remember what happens here is that if you differentiate this so you are differentiating this with respect to x. So when you differentiate y using the power rule, this is the same as this d over dx like that, and this is using power rule, meaning 1 has to drop, multiplied by y like this, then y minus, or 1 minus 1, because y simply means y to the power 1. So using the power rule, the derivative will look like this. And then this side it will be d dx. This will be n multiplied by x, then n to be subtracted by 1 like this. Then from here you continue, you work out this. So you've seen here, when you do the derivatives, the secret here is that, or the rule is that, if you are differentiating the variable you've differentiated, you need to multiply it with the d on top. So since we've differentiated this has got the variable y, so we are going to multiply y by this, meaning this will be dy dx. Then when you work out this part will give you 1 times y to the power 0, which is equal to, then this, remember this is the derivative of x, so the x will be multiplied with the d on top there, so this will be dx over dx, then this will be n x, this is times here, minus 1. So when you work out this part will just give you 1, because any number to the power 0 is 1. So 1 times 1 is just 1. So you're going to have, then this part, dx and dx will cancel. So no wonder the derivative is written like this, dy over dx, dy dx. It means you are differentiating the function y with respect to x, then using the power rule you are going to have something which looks like this, n times x to the power n minus 1. So this is the power rule. Make sure you take note of this. This will help you when you start doing implicit derivatives. You should know what happens when you differentiate something with respect to x and the thing you are differentiating, or the variable you are differentiating, isn't x. So in this case, let us do some examples, only 2 examples on the power rule. So doing that, let me erase this, or I just reduce it this side. Okay, just erase to create more workspace. Okay, we continue. So example number 1, let's say example here. Given that the function is this 2x squared plus 3. This is example 1. Then example 2. So you can try this. Pause the video and do this so that you can come and compare the answers after I solve them. Then you've got this as well, y. So let me say g. Okay, g is equal to t to the power 3 plus 2t squared minus 3t plus 4, like this. So let me start with the first one. So answering the first one, the answer is like this. So we introduce the derivative sign, so this will be d dx of y is equal to d dx of this 2x. So we are the question is differentiating this with respect to x, like this, plus 3. So when we work out this, the derivative of y is just 1. Let me do this. The derivative of y is 1 times, since we've differentiated this y, it's a variable y, so we multiply it with the d there, it will be dy dx, like that, times 1 is equal to, then the derivative of this will be 2 multiplied by 2, which is equal to 4x, then 2 minus 1, we are using the power rule. Remember, the power rule is like this, the derivative is like this. So try this at your free time. So this will be just 4x, then this part will be 0 because it has got a 3x to the power 0. Remember, any number to the power 0 is 1. No wonder there is a 3 there. It means it has got x to the power 0. Then using the power rule, differentiating this 3 is equal to this 0 times 3 x 0 minus 1. So any number multiplied by 0, this entire thing will become 0. No wonder this 3 will be 0. But this derivative has been differentiated with respect to x, and the variable we are differentiating is x. So it will be dx over dx. And this will cancel, and this will cancel. Dy dx multiplied by 1 is just dy dx. So wait, my mouse is performing. Let me just do this. Is equal to 4x, and this is your answer. So this is the power rule. We solve the power rule using this. So given this example, you can try out this. Pause the video, you try question 2 before I solve it. Okay, just a minute, continue. Alright, okay, so let me erase this. Erase this. This is the answer to question 1. If you found this 4x, then you are correct. Let us do, so I'll do it very fast regarding that you know how the derivatives are done. I won't be showing the basics like I was doing. So differentiating this will be dg over dt. Just wait a minute, mouse. Alright, so this will be dg over dt, meaning you're differentiating this function g with respect to t. So this will just be dg over dt is equal to, so this will be 3 t squared, this is the derivative of this, plus 4t minus 3, like this. This is your answer to question 2. This is your answer. If you found this, it means the answer is correct. Let us move to the chain rule. Okay, the chain rule. So remember to subscribe to the channel if you haven't subscribed yet, and always like the video, comment in the comment section where necessary, and turn on the notification icon so that you don't miss out of any update. This is your rare tutor. So chain rule, the rule is like this. If you've got something like this, let's say you've got a function, let's say y is equal to x to the power n, like this. Let's say x plus 1. Let me redo it. Okay, let's say you've got something like this. Let me just rub. Okay, you've got something like this, x plus 1 to the power n, like this. How do you differentiate a function powered to some, a function which looks like this, powered to some number, has got a certain power? So you are going to use the chain rule to derive or to differentiate mainly some trigonometric functions, trigonometric functions, and some of the exponential functions, even logarithmic functions. We use the chain rule. So differentiating this, you say you let x plus 1 be equal to u, then you let n be equal to v. So these are just assumptions. You can use your own letters of your choice, still fine. If my name is Joseph, I can use J here, it's fine, but for simplicity sake, use u and v. So when you do this, meaning you attract a differentiation, so you derive this or you differentiate this. Let's say differentiating u will be du, the derivative of u with respect to x. So doing that, you're going to have differentiating this function with respect to x is just 1, because this will be a 0. Then this will just be equal to du is equal to dx, like this. When you cross multiply there, you're going to have du is equal to dx. So you keep this one, or you just keep du dx is equal to 1, like this. Then differentiating v is equal to n, so you say dv dn, meaning derivative of v with respect to n, this is equal to 1 as well. This is equal to 1. So differentiating this in the chain rule says that dy, sorry, let me redo this. Okay, even this. Okay, the derivative of y with respect to x of this function is equal to this. du dx multiplied by what is it? Okay, so this is equal to times dv over dn. So the general formula you're going to be using is this: dy, let me just redo this, dy dx is equal to du dx times dy du, like this. Let me just write this one properly. So this is your general formula. I'm going to illustrate what I meant by doing this using this example. So you have to compare something. So let me erase this part, or I just reduce so that you can be comparing. Let me reduce it to this corner. Okay, so solving this example, let's say we've got y is equal to the natural log to the power 2x, like this. Or maybe I've jumped. This example is too complex, you haven't reached this part. Let me give you this one, because this one is another topic which is ahead. So let me just give you this one. Y is equal to x plus 1 to the power 2x, like this. So to the power 2x, like this. So in this case, we'll say let u be equal to x plus 1, like this. Let me just rub this. This example is very simple. I rub this. So this is just a 2. This is a 2 to the power 2 there. You let u be equal to x plus 1. Then in this case, you're going to have y is equal to u squared, like this. Then you can differentiate this. This will be dy du with respect to u, because the variable here is u. This will give you 2u. Then differentiating this first equation here with respect to x, we are going to have du dx is equal to 1, like this. Then following this general formula here for chain rule, we'll say dy dx is equal to du let me just write properly, my pen is tripping. This will be du dx multiplied by dy over du. So here the key part is that these two should be able to cancel so that they can give you dy dx. As you can see, du and du can cancel. So this is how you can master this formula. If you think like it's hard, it's very easy. Make sure you just swap these two. These two should be cancelling each other, because when you multiply this, it will give you dy dx. So using this formula, we'll substitute. This will be equal to, where there is du dx, we put du dx. Du dx is 1 multiplied by our dy du is equal to 2u. So this will be 2u multiplied by 2u, like this. Then this 1 times 2u, it is just equal to 2u. Then remember, wait, the u isn't good. It is 2u. So remember, our u is this. So where there is u, substitute by this. So our final answer is equal to 2 multiplied by x plus 1, like this. So this is our chain rule. This is how you can do it. So there is a shortcut, but I don't want you to be using shortcuts. Always do the correct procedure or the correct method. So the shortcut is like this one. Let me show you. Let me just reduce this. I'll solve the same example using the shortcut. So I had this function y is equal to x plus 1 to the power 2. So the shortcut is that the derivative of this with respect to x is equal to, you drop these two, or the power, you drop it like this. Then you maintain what's in the brackets there. You've got x plus 1. Then you multiply it with the derivative of your power there. That will be your answer. So this power, you subtract it. You say this minus 1, like this. Then you multiply it with the derivative of what's inside. So let's do this. Multiplied by the derivative of what's inside, which is just this. Sorry, it's this d dx of x plus 1. dx plus 1. So this is how you can do it, meaning our dy, my pen isn't writing well today, don't know what's wrong. Our dy dx is equal to 2 in the brackets there, x plus 1. 2 minus 1 is just, so you can rub this part, this minus there. I meant to subtract by 1. Some people can be asking, how about that minus sign over there? So 2 minus 1 is just 1. Then multiplied by the derivative of this is 1. So inside there you're going to have 1, because this will be 1, this will be 0. Then going forward, this will be equal to this 2x plus 1, like this. It's terrible. 2x plus 1. This is how you can do your shortcut in chain rule. So you just drop the power you have there, you multiply it with the same thing you have in the brackets, then that power subtract it by 1, multiply this by the derivative of what's in the brackets there. This is the shortcut for chain rule.